And good afternoon, and welcome to Manure Mondays, March 6th edition. My name is Andrew Barry. I'm with the Ontario Ministry of Agriculture, coming to you live today from beautiful Elora, Ontario. And boy, we had a great week last week. If you remember, we had Vince Herbrook here from Herbrook Farms, Herbrook Poultry Ranch. It was a poultry ranch, very large operation, but doing some very novel stuff around value-added manure. So we had a good conversation there. We're going to continue the conversation today, different topic, actually picking up on a topic from last year that we started, looking at composting bedded pack barns. So as we get into it, just a reminder, folks, please stay muted, but do not stay inactive. We want you on the call. We want you on the chat, looking for your questions, your comments, and interaction with our speakers today as we get into this. There will be 2 credits offered at the end today. One is a CCA credit. So if you're a certified crop advisor, that QR code will be posted. But we also have a off-calf credit, okay? And this is a knowledge sharing event for folks who are involved in Ontario in the off-calf program. You know who you are. So you also can get a credit for this, and there will be a QR code at the end for that. So watch for that, but let's jump right in here. Let me introduce my 2 colleagues that are speaking here this morning, and Dr. Tom Wright, who you see in the blue, and Tom is a dairy specialist, and Christoph Wand, who is a livestock sustainability specialist. Probably if you got 2 of these guys together for a conversation at the bar, you would end up talking about nutrition somewhere along the line, because by background, both of them are nutritionists. So that may come through in the discussion today. But I'm going to turn it over to them and just warn you ahead of time that these guys have been given free rein to interact with each other, to interrupt each other, to jump in back and forth, and you can do the same. So take it away, guys, and let's have a good conversation about composting bedded pack barns.
Okay. So yeah, we are going to jump back and forth, Tom and I, and we will go through our slides as somewhat, I won't say haphazard, but in a pretty fluid manner. Okay, so some of the things we want to get through today is to review the building envelope. And I did some of that the last time I was on for Manure Monday in January of last year, and just talk about how the building and its design makes for some of the critical management features. One of the new things we're going to offer today is an update on the University of Guelph project that is underway, and I'll turn that to Tom mostly. We're going to have a good discussion here today on manure value, and then this whole idea of whole farm nutrient balance and pack management, and hopefully we'll have left time for a discussion with all of you. I'm just going to move my control bar here. There we go. So Tom, I'll leave this to you. You know the history on this as well as I do, so go for it.
Yeah, so we started working on this pack barn project of ours that's into its 6th year now. Back in 2017, didn't know a lot about pack barns myself, and there wasn't much aside for one fact sheet on our internet. And most of the questions I was tending to get was from dairy producers asking things like, how much time does it take to start, to till one of these packs if you have one? How often do you have to do it? It was really a labor orientation to the questions, not so much like a how-to or compost type questions. But that's where we started trying to answer some of those questions. When we got into it, working with the cooperating farms, we realized that they had way more questions as people operating these systems than we were kind of prepared for, and that's kind of what led us to multiple years of summer student projects trying to get a handle on some of those. We quickly learned that it's not a system for everybody, but those that are in it and managing it really passionate about it for sure. So they're keen to keep it operating like they desire. They certainly want to see everyone successful in these systems. They think there's a huge advantage to them in terms of some of their own thinking around cow welfare. So it's been a really good collaboration with the farms that we've been working with, the students at the university, the faculty. There's a whole team that's behind this now, and that's really it's been really good to see.
You want this one, Tom?
Sure. So composting basics, really, so the cows are basically on a pack. There's no stabling, there's no stalls. They're just free to come and go as they wish. So they're basically in a pack that is regularly subjected to the addition of, in most cases, sawdust. So this is added to the pack every day where the cows are lying. It's worked twice a day with some kind of implement to oxygenate it, and managing the nitrogen that the cows are depositing on the pack. Manure is really this balance in the art of making the compost pack work as best it can. So the cows are adding the nitrogen, the farmer's adding sawdust as carbon, and the carbon nitrogen ratio is what's kept in play. The byproducts here: heat, water, carbon dioxide, other gases. So it's a very active system. We're trying to make sure that the cows are clean, comfortable, dry as best they can, and we can kind of tell when it's starting to go out of the range of optimum, when we start to see temperatures going down or moisture levels going up. Ideally, we're looking for a uniform mix and keep the cows on a year-round setting. But we know in this part of the world that winter, fall, early spring tends to be the challenging seasons for them.
You want to talk about heat, Tom? Go for it.
Yeah, so heat is the one thing that producers, if they're not taking temperatures of the pack, literally with a thermometer like we would do if we were out to troubleshoot a farm, they've got other ways of measuring sort of biology, heat production. So this time of year, steam is certainly something that they'll encounter. On really cold days, the fog in these facilities is quite thick. It tends to blow off with good ventilation in a matter of 10, 15, 20 minutes kind of deal. But it can get very thick to the point that you don't see the front of the tractor if you're working the pack. Heat is really good for this because it drives the evaporation. Evaporation is something that's just you can't overestimate how important evaporation is in these barns, because it's really, there's nothing exiting the pack essentially in the way of moisture out the bottom of the barn. Like, there doesn't tend to be any concrete at the base of these packs in Ontario. But what we see is that all the evaporation that has to happen to remove that moisture out of the barn and keep the pack dry, a lot of that is temperature dependent of the pack. So the more active your pack is, the better you are at able to mobilize that moisture. And from a dairy production standpoint, the warmer we can get our packs, the better it is to control pathogens and somatic cell count and all the milk quality parameters that dairy specialists are interested in as well.
Will I tackle this one, Tom?
Sure.
Okay, so this is data one of our students a few years ago, Olivia Willoughby, queried Dairy Farmers of Ontario through some of our relationships on campus. And all this line shows you is that over a 1-year period, a small group of producers, 15 to 20 at the time, I recall, is the blue line, and that represents their somatic cell count, which is one measure of udder health or milk quality, depending on how you wish to look at it. They're the blue line. The red line is the provincial average. All this says is that it is possible. Some people say immediately because, it's a living system that milk quality, udder health must suffer. And this is data that quickly shows you that it does not need to be that way. Tom, you want this one?
Yeah, so similar kind of data here. So we often get people converting to compost barns coming out of tie stalls in Ontario. So we looked at some data from, 14 or 15 farms. We've got a bigger data set now, but at the time we put this together, basically we tracked milk quality, somatic cell count before and after. So we had a set number of time periods before and after to be as representative as possible, so that we weren't biased towards whether they were in summer or winter when they made the switch. And here's, I think it's 14 farms. I think it's 7 are up before the conversion and went down, and 7 are down and then went up. So it is possible to do composting and switch without necessarily affecting your milk quality and somatic cell count for sure. So it is possible to maintain or improve, and certainly in a learning curve in a new system like this, it's not surprising that some people are faced with some initial challenges as well, but it is possible to maintain or get better.
You're on a roll, Tom.
All right, so we talked in that previous slide there about temperature of the pack and evaporation and moisture control. So this is really just a graphic we put together to convey the importance of it. So in the dairy world, the cows right now in the code are required to have about 120 square feet of usable pack space. And what we see from our own experience here and mobilizing, that really amounts to, like on that, is that they have to mobilize literally a ½ liter of water per square foot of pack space every day. This is highly dependent on air movement in the barn, temperature of the pack, air temperature, the differential between the two, and relative humidity. So high relative humidity, it's sometimes a little harder to mobilize that humidity out of the pack as well. But you're literally moving on a 1 cow unit of space of 120 square feet, 50 to 60 liters of water per day. And some people really have trouble, wrapping their head around that when they first hear it.
Okay, I'll tackle this here for a bit, if that's okay, Tom, and jump in. So let's talk about the pack area, because this is going to loop back in. I did talk about this on the Manure Monday last year, but we need to come back to this at the end of the presentation today. So we need everyone to be on the same page about how these barns are designed. So what you're seeing here on your screen is a cross-sectional view of a dairy barn. So that little vertical black line is the head rail where the cattle are being fed. Where that red arrow is the transition area between what would be the pack and what would be the scrape alley. And this reference to continuous access is this idea that cattle can get from that pack area anywhere in the barn to anywhere on the scrape alley. We'll show you pictures around that. And then we have to design the barn accordingly to what we want to do. So this is one picture of a continuous access barn. And so we're going to show you some pictures here again. So there, other than the beams, or the posts more correctly, holding the ceiling structure up, there's really no barrier between the cattle that are on the pack, on so sawdust appearing background, to the foreground where you're seeing the feeding area. This is in contrast to a limited access barn, and the reason it's in red is because I need to remember to tell everyone that this is not what we are recommending at this point in time. That limited access barn, and this will come back to our conversation at the end. Okay, so just to retract that ground, so limited access, we are recommending against this design, and what you're seeing is where each of those red arrows is, there's a concrete partition. You'll still see there's beef feedlots built like this today, where there's basically a concrete barrier between the pack and any kind of scrape alley or the bunk or feeding area. And that's what you're seeing here. But what it does, it forces animals into a very narrow band of traffic on and off of the scrape alley, and it causes for significant problems in terms of pack condition and so forth. And we'll talk a little bit more about that as we go. So here's yet another example of a continuous access. And the point of this one is, other than, the middle of the pictures being obscured by those fans hanging from the ceiling, there was that concrete curb on the right-hand side. I'm going to turn it back to Tom to talk a little bit more here about the university study.
Thanks.
So we got involved with the University of Guelph, and they were fortunate enough to get some funding from the various sources you see here listed along the bottom of this slide. So it's a real cooperative effort from different universities, different provinces, provincial governments, etc. It's was a real advantage for the research that's going on here, because as Christoph and I started into this, it was based on summer students and our availability to do some work around those, essentially between May and September. So composting between May and September is a different challenge to those months when it's cold and freezing outside and the pack conditions change. So the university's got funding in place to do their work, and they're able to do year-round studies. So the data collection we're going to share here was updated to the cooperators a week or two ago. and it's data up until December 31st. It's the first time we've actually been able to share data from the start of the winter season. So next slide, Christoph, please. So this is just a list of some of the same sort of people that we're seeing here. Angie Wilson's the postdoc involved in the project. She and her team have been making multiple visits. So every couple of months they're there at the farm. And the principal investigator for here is Renee Bergeron at the University of Guelph, and she's leading this team of researchers. So the goals of the project overall, there's a lot of different goals, but essentially the main goal here for this project is to identify some of the best management practices for Ontario compost bedding farms. So they're looking at all the different management techniques that are out there, all the different substrates that are going on out there. They're collecting all this information. They're collecting in-barn measurements from animal health and welfare standpoint, milk quality standpoint, cleanliness standpoint, temperature and conditions of the pack, moisture in the barn. All these sorts of things are going to be bundled together, and we're expecting the project will be able to figure out some of the best management practices that are, maybe even have differences in terms of seasonality and time of year.
Shall I, Tom?
Sure.
Okay, so this just gives you a rough idea of where the farms in Ontario are located, and frankly, a lot of it is designed about where can the research team get to fairly quickly from the University of Guelph. So this is a good group. All those forerunner projects that Tom and I were involved with, you know, we had 15, 16, 17, approaching 20 farms, but 25 farms on this project. AMS, for those of you not in dairy speak, that is automated milking systems, so basically robots. And 9 are parlors, so they have their hands on udders daily. Average of 83 cows on the pack, with a good range from small to very large herds. And the average square footage per cow across the project is 124 feet, which aligns fairly well with the code of practice, which is 120. All that said, I think you would see Tom and I are both advocates for a smaller square footage per cow, but that's a whole different conversation. As we can demonstrate that some of these barns can be very well run at a lower square footage. So that's what the study participants look like at this time. I'll speak to this slide too, because it comes back to our discussion later. So we're seeing a multitude of beddings showing up in this U of G project, which is interesting. Tom also already mentioned the gold standard of sawdust, which we'll come back to again, but we're also seeing some of these wood byproduct, MDF would be one of them, medium density fiberboard. We're starting to see more producers using straw and corn stalks, and a few of them are on the study. So these 4 bedding types are what we're actually seeing on the study as per Angie Wilson's data collection. And again, we're starting to get data. There's this whole discussion, this subculture about, you know, should people in these barns be rototilling? Should they be using, you know, whatever, just field cultivation equipment repurposed? And then there are also people in the market on the right-hand side of your screen. That's a purpose-built compost bedded pack barn tiller. So that's being sold to dairy people specifically for that purpose. So we're seeing these across the study. And we're also seeing these frequencies of twice a day, which is what we would say is the best practice, once a day, and some, frankly, less than once a day. Tom, I'll give this to you.
Yeah, so we've been monitoring farms for a while. This is Angie's data from the university study. So she measures pack at 30 centimeters depth. We've done some work in the past where that tends to be the most active temperature that we tend to take. So we've done some work comparing 15 and 45 centimeter depths. We generally go for a 30 centimeter depth just for consistency. It tends to be the hottest wherever we measure on, regardless of farm. So this is the 25 farms that she's been collecting data from. You can see here our recommendation is in that 43 to 55 degree sort of range, that green band along the top. And you can see that, you know, there's about a third or so of farms that are in that range. And then there's a couple of 2/3 that tend not to get there. And they tend to be lower in the colder time of the year, as you probably would expect as well. So there is an influence of time of year on pack as well, but it's certainly important to make sure you've got good temperatures regardless of the time of year. We would probably be more lenient towards accepting pack temperatures in winter, because there's a difference between achieving 35 in February and it's cold and achieving 35 when it's August and hot. So there's a bit of a relativity to what you're achieving and when as well. So moisture and temperature are, go hand in hand. We like to see it in this green range here of between 40 and 60. 55 is like a really good number I like to keep in my own head. 60, the tipping point beyond 60 is it tends to start getting wetter and stickier conditions. So we like to see it 60 and below. Sometimes achieving that requires more sawdust use. It's often indicative that you're managing sawdust more from a moisture control as opposed to a temperature composting sort of approach. But we're looking to stay in this range to achieve optimal temperatures. And once you start get too wet, it's starting to displace oxygen with moisture in those packs. So it's a balance. I mean, it's expensive to put enough carbon down sometimes, but it's a bit of a trade-off between if you're not achieving enough temperatures to drive off the moisture as well. So it's a bit of a trade-off of those two.
Okay, so some of the other data that's being collected are the management practices around the packs, the respiration activity, so the biological activity of the pack, some of the bulk tank milk quality stuff. So again, there's milk quality members on the team as well. And then looking at some of the cow care, which is Dr. Bergeron's ultimate interest in this whole thing, is looking at these as a best situation for managing cows into the future. The Dalhousie lab, because that's part of the interesting part here, is looking at the composting itself, right? So this is a big multidisciplinary project, and that's where I think the people on this call may be interested. So going down the road, again, this is an active compost. This is not finished compost. So there's still things we need to learn about carbon nitrogen ratios, solids, porosity, again, the respiration of the pack. What's the ammonia flux? What's the greenhouse gas flux? Those are some of the questions we would like to see in the big picture coming out of this project go forward. So one of the deliverables that's already come out of this project that's going to be reported on is a project looking very specifically at the impact of those big fans. So those are the big diameter fans. What is the impact? Because we've had all sorts of discussions. Tom and I debated for the first number of summers, any number of theories, why cows congregate. Producers were always seeing that cows congregated. And you could make up a theory and discount it as quickly based on other observations. So Angie and her team went about looking at this, and they've, again, made a deliverable of this already. So looked at 4 farms specifically with these fans and wanted to look at the association of the fan and all these parameters that you see on the screen with the conditions of the pack. So in short, where the wind speed is higher in the summer, moisture is higher because cows are congregating, and pack temperature is lower. So we definitely see an impact of that where the cooling effect is better on the pack. Cows congregate, they drop more moisture, and pack heating conditions in terms of keeping the composting activity going begin to suffer. So that is going to be data that is going to be reported upon at the American Dairy Science Association conference, which is going to be in Ottawa this year. But beyond that, they're going to be into their 6th visits. And as Tom pointed out, the importance that this data is actually being collected through the winter. So once that's done, then this project is going to recalibrate, and they're going to have these focus groups in April and look at what management changes they can do together as a team to try to optimize pack performance on the various farms. So they'll all have a chance to basically tweak the recipe and go forward. So switching to the next phase, and this is hopefully of interest to many of you here today, is linking these pack barns to cropping systems, which was a discussion we had started a little bit last January. And there's two things happening here. Tom has mentioned it and the data mentioned it, you know, these questions around milk quality, animal health, animal care, but also this idea of what is the nutrient asset that is in that barn? You know, we get questions like, you know, do these barns count as their own manure storage and so on and so forth. But there's another question there. When the pack fails, people clean out. And so one of the things we want to do is start moving these buildings towards using the nutrients inside them towards their highest use in the cropping season. So just going to give you a little bit of sense of what happens in one of these barns that clean out, just so you can see for anyone not familiar. So this is pretty typical. On the left side of the screen, the pack has already been cleaned out. We're just using a hot wire here quickly to keep the clean part of the pack, or the part that has been taken out, separate from the right side where we're actively working with the machinery. Typically, they'll take the active compost and have scraped it over and kept it on the side where they want to keep it. And in this case, they're taking material out and they're getting ready. This is a head of corn ground in the spring. So this is early May. So this is a video taken just north of the Guelph area here. So that's pretty typical. Splitting the pack, taking the material that needs to go to field, and applying it, hopefully, in the cropping season. Tom, for you.
Yeah, so there's a whole range of what people have tried or consider as the management that suits them when it comes to clean out. I think we've heard it all now, but occasionally a new one pops up. So I've heard everything from routine clean out every 6 weeks, which was a new one for me, and that was just recently. Twice per year is pretty standard for a lot of operations, so they just like to do a spring and a fall clean out. Some choose to do it annually. Some have gone a couple of years and counting. We've got one that's 4 and counting. I think he's on the verge of going to 5 years, never clean out. And some are actually hoping for never as the answer. So there is this complete range of moving that material out of the barn for different reasons. Some just think it's appropriate management. Some think they don't want it building up inside the barn. Some just think it's nutrients they want to use, and some just think the pack is in such good condition that they don't want to tamper with it. So it's kind of the if it ain't broke, don't fix it kind of approach.
Some of you are wondering, because many of you are clever manure people, what kind of foolish perpetual motion machine it is that Tom has just started talking about. You know, how can you have a barn that never cleans out? And just so no one thinks that we're into conspiracy theories like the movie Envy, I hope everyone remembers or is aware of this movie where Jack Black's character invented a spray that when you sprayed it on your dog poop, it made it disappear. And that's not what we're suggesting is happening in these barns. We're hoping to explain something a little more rational than that. And it comes to these questions, and I'll give a few slides here on perspectives on manure. And this is typically how you see a barn, or people when they go into these composting bedded pack barns see the barn. So left picture, you know, is the headrail, nice TMR ration laid down for these dairy cows. This is the same barn on the right-hand side, the lower picture, you know, those cows resting on the pack that you see, you know, that's at the back of the pen. Perhaps a more helpful and accurate assessment of what the pen and pack environment looks like is a picture like this, where you can see that scrape alley. If you remember back to the discussion a number of slides ago about continuous access. So this is a continuous access barn. And again, when you look at the pack like this, you see that in reality, in terms of square footage, there is a dynamic between what is actually the pack and what is the scrape alley. And we want to dig that up a little further here.
Christoph, just on this picture here, just to back to the point of the perpetual motion there. So in winter, the amount of manure in this pack area is going to build up along that concrete sidewall there. So it'll increase 2, 3, 4 feet in some cases. In the summer, if they haven't cleaned out and they get good pack temperatures, You can see that staining on the wall there about halfway up. There's a kind of a line that runs along through. We can see that this pack will actually cook down 2 to 3 feet in the summer. So it is this cycle of buildup in cooler, less ideal composting conditions. And then when you move into this ideal summer weather, you can literally see some of these compost barns, like the pack literally drops 2 to 3 feet and you're just left with staining there. Sawdust use in the summer is usually about half or less what it would be in winter. So yeah, definitely it's not a magic thing. It's just the temperatures and the breakdown process.
Yeah, and you know, this is what you've described, Tom, is something that I call riding down the carbon, right, in the summer. And this is why people choosing to clean out barns in spring without having depleted the carbon that's built up in their pack becomes a real loss. I think it's a measurable loss we could wrap our minds and pencils around if we started to look at it that way. And I think those are some of the things, you know, this observation you're making, Tom, relates to what I hope we get into before we've all left the call here today. That I think there's some real economic incentives to managing these packs better. And what you just described is an important observation towards it. So here again, back to this scrape alley pack dynamic, and that line Tom was describing, you can see it on the back wall, and this one again too, where they've ridden down the pack over time. And again, here's that scrape alley and understanding the importance of it. We keep talking about these, and I'm equally guilty of it, as composting bedded pack barns, but there is this significant feature of this scrape alley at the front of these barns. This is a picture from one of them. And what I want everyone to see is the difference between the manure at the top of the picture and the bottom of the picture. The top of the picture is compost material that has tracked out on the hooves of the cattle. This particular one was a restricted or limited access barn, right? So they're coming through those discrete holes in the concrete wall. But point is, they're tracking that pack manure. The composting material is being tracked onto the scrape alley, and in this case, at the top of the picture. Whereas at the bottom is just plain old regular liquid dairy cow feces, right? So that's the difference between the two material phases you're seeing in this picture. So the question becomes, what is this? So if this is a dairy farm and that scrape alley is taking that material out to this tank, what is this material? And I have to say to, you know, the group assembled that I'm increasingly having a discomfort about whether or not we have the right answer to that. So we need to think more about this liquid phase. We need to think more about the tracking out of the pack onto the scrape alley as a clean out method. We need to think more about liquid storage capacity. And I know early on, 6 years ago, when we were working in these systems, the numbers we, OMAFRA, had in our MStore, so the nutrient management software calculations, were not right, frankly. We need to think more about scrape alley design. And so that's the, you know, this sizing question. And by sizing, I mean, what is the width or the depth of the alley, however you want to talk about it. So I'm not talking barn length. I'm talking about from the headrail where the cattle feed to that curb in that continuous access barn. How big is that scrape alley? What's the relationship of locations? And Tom, I hope you jump in here in a moment and talk about the implications of multiple alleys and the layout too. So I hope you speak to that as an example here. But I just want to say that I suspect, and this is somewhere we need to go, is that the nutrient content of scrape alley material from these composting bedded pack barns and liquid scrape alley from a freestall dairy are going to be very different materials. And we can talk about that again in a moment. But Tom, I hope you can jump in with that example, please.
Yeah, so we, you know, when I think back to 2018 and we were talking about some of our initial work on design for these facilities, we were very conventional in our approach, where it was like the pictures Christoph shown, where scrape alley, pack, curtain, sidewall kind of approach. We've seen a couple of different systems now where there's essentially a scrape alley on 2 sides or both sides or all 4 sides of the pack. So think of like a sandbox within the barn kind of approach. it's changing the dynamics of that dry material staying on or off the pack. I think it does change the cost. I mean, when you've got some of these barns that are spending 30,000 plus on sawdust a year, it's an important resource. And I think we need to, as Christoph mentioned, we need to figure out if the economics are differences versus.
We just lost you there, Tom.
And I'm back.
Okay.
So it's just a question of whether some of these differences with a larger scrape alley or multiple scrape alleys is whether it's preserving the value of the compost versus an approach where the pack is getting wetter and it lends itself to a management where it's twice or annual clean out. So I think those are questions that we haven't fully wrestled down, but they're certainly interesting now, and there's more interest all the time in when nutrient costs are so high as to what the right answer is. And certainly sawdust is certainly more expensive now than it was in 2017 for sure.
So yeah, on the topic of sawdust, so some of you asked the question, how do they put the sawdust on? So this is just a pretty typical picture. Many of them use their manure spreader, load it up from wherever they store that sawdust, drive it in on the pack and let her whirl, right? So they use that same piece of equipment for that. There's a few other variations how people do it, but it's pretty low tech. And some variation around that in the industry. Tom has identified our conventional thinking of previous, and I would say we probably, and I think most people do, look at this as a pretty linear equation, that the nutrients that come in up till now, we've talked about nutrients in a different context, but the nutrients that come in with the cow, so, the nitrogen, or we're nutritionists, we think of it as crude protein, you guys think of it as nitrogen. So crude protein, phosphorus, potassium, all the micro minerals, et cetera, undigested feed. We see that as being an input from the cows to the pack, sawdust being that purchased carbon source. We'd till the pack and we'd make some compost, right? So this looks pretty much like, your first year respiration kind of stoichiometric equation. But I've been thinking about this a lot, and I have to take blame for this, and Tom's allowed to jump in whenever he wants. So sawdust is still the gold standard. We're not suggesting anything besides that. But the call we've been getting more and more, I can't get sawdust. My sawdust is delayed. Sawdust can't be had. What do I do? And, this can lead us down a rabbit hole about, where's the sawdust going? Like we're told there are mountains of it in northwestern Ontario. We hear trucking logistics challenges and all these sorts of things. We hear rumors of material having been diverted to Europe as a biomass source. We have no evidence on any of those things, but we know our producers who've committed to these barns are running short. So what do? Sooner or later, people turn to chopping straw into these packs. Some have had success. Some of them you've seen are on that U of G study and they show up in that data. Point is, do we know what we're saying to these people about the use of on-farm grown carbon sources, the corn stalks, the straw? Do we know what we're saying to them? I know in the beef world, some of the feedlot operators I work with, they would bale their corn stalks in the spring so that all the nutrients have leached out of corn stalks before they use them as bedding. Do we need to start having more robust and nuanced conversations with our composting bedded pack dairies about what the harvest protocols would be around those materials, how fine they need to chop them? Like, these are all important questions. That's why sawdust works, because it's fine. What do we do about these things if people are going to have to depend on their on-farm grown carbon sources in the future?
The the reason why sawdust is the gold standard, in many cases, it's a carbon nitrogen ratio from the material. So sawdust itself is going to be like 500 to 1. Pardon me. And some of these stovers and straws are going to be 60 or 70 or 80 to 1. So there's an inherent advantage to sawdust. And then there's the processing cost of the on-farm materials to get it to a small enough particle size as well. So there are competing economics to them. Supply is clearly something that keeps compost guys up at night if they don't have access to sawdust, though.
So all this discussion, and Tom and I made a road trip 2 weeks ago, and composting bedded packs were central in it. We visited a few of our clients on a 2-day trip, which we hadn't a chance to visit with in quite some time, obviously because of COVID, etc. But all these things have been rolling around in my brain. So this is something I drew up yesterday, and Tom can't take blame for it. And this is how I'm starting to look at it now, that there is a circular interplay between these things, especially if people start using straw from their own operation. So this revised equation that I'm showing you, so sawdust may or may not be coming as an input to that pack anymore. I think we need to think more about that scrape alley liquid, right? So in the previous version of this graphic, I showed you a linear relationship between the pack and the compost going out of the barn. And I think we need to have a more sophisticated relationship between the scrape alley liquid and what does it look like. And again, you can't just use the data from a conventional freestall barn. I don't think it's working, especially in those barns where someone is achieving 4 and 5 years between clean out. It means that material, the nutrients leave the barn somehow, right? This is not like Jack Black's character in Envy. The nutrients are leaving the barn somehow, and we need to figure it out, and we need to figure out the density in which they're leaving. So I'm looking at this now that aeration is this process, and maybe some of the compost is coming out of the barn. Maybe some of it's going out in the scrape alley. And then as we're looking at the straw, we need to look at the straw now in the same feedback loop we would have the dietary constituents, say the alfalfa crop or the corn crop, in terms of what are those contributions back to the pack if we're trying to do this as a whole farm nutrient balance piece. So this is what I think we need to be looking at going forward. So today, I hope we've covered this, why the building envelope and the building design, and I hope I've made the case to you that the scrape alley intersection really does matter, especially as we run these barns better and better. We've given you a bit of the update on the U of G project, and happy to turn you over to that project team if you want more information. I hope we've had a bit of a philosophical conversation about manure value and this whole farm nutrient balance and pack management philosophy, the perpetual motion machine, and I'm hoping we can still have a discussion here in a moment. But first, shameless promotion. This wouldn't be a presentation without me giving a shameless promotion. For any of you that are more on the cattle feeding end of things, on Thursday night, the Ontario Corn-Fed Beef Program has been partnering with our beef team on a number of webinars. We're into our 4th now, and this time we're going to specifically look at this intersection between corn grown for the Ontario Corn-Fed Beef Program and our feedlots, and what are our on-farm farmer feeders doing about improving the footprint around their corn crop relative to their beef operations. So that's it from us.
Excellent. Thank you, gentlemen. So yeah, definitely some things to discuss and hash out a bit further here. So first of all, I want to go to a question that came up in the chat, and there was also a comment in the chat. So one person on the line has a number of barns, and they are set up as limited access barns. And I'll requote what you said, they're not recommended. So just drill down on that, because somebody else was asking about those, that is compaction the issue there. But just to be really clear, why are you saying they are not recommended?
Do I have to go first, Tom?
Sure.
So Tom and my gig, for anybody who wants to know how it works, is I shoot from the hip and Tom actually thinks about things. Okay. So it's because those access points become shitty, wet messes. Like, let's be frank about what they are. They become a cow traffic problem, and they become a dominance problem. And Tom can speak again to the advantages of the second alley and stuff. He's more a dairy cow guy than I am, but they just don't perform well. Like those limited pinch points, right? It's like any pasture field. It's like any tractor gate. Anytime you force traffic through a bottleneck, this becomes a problem, right? And we see that in those barns too.
Yeah, I think I agree with everything Christoph said. I wouldn't, it's not to the point where I would tell somebody to rip out their access points. It's really something in terms of somebody building new today. I think we would recommend against that. So it's from that context that we say that. Partly the code when they're talking and I mean the dairy code of practice. So right now, and it's literally probably weeks or so away from we'll see a revised code come out. The current existing code as of today calls for 120 usable square feet of lying space. If you're gonna talk usable, then those wet, high trafficked areas are not places where cows will lie. So it doesn't really become usable. So you've got a space there that is not counted as part of your 120 square feet. So you're deducting off unusable or unliable pack space. So it really compromises you in terms of your 120. So yeah, I think we just see better overall pack conditions when they can freely come and go in different areas. There's an element of compaction. There's an element of manure being deposited in defined areas. They eat, they've had a drink, they take a few steps, they have to go through a funnel. It just creates a really high moisture environment. So compaction, moisture, no chance to lie there. Yeah, it's reducing your actual usable pack space.
Okay, so Jim Hyde, you were the one that made that comment. Jim's with NRCS, so feel free to unmute, hop on if you want to make any comments following up on that, Jim. Be glad to hear from your experience if you've noticed anything different. But anyhow, I'll just allow you to jump in, Jim, if you want, or into the chat. I'll never forget the first time I went into a compost bedded pack barn, and you mentioned this earlier. You mentioned the fog. And I was there at a time when it was being actually cultivated, is what he was doing. This is quite a few years ago. It was an earlier version of one. But boy, that fog in the barn was like you could not see very much because of that. So just wondering, one of the things we haven't talked a lot about is air quality. Is there any issues around air quality with this type of system, with the animals right there, with the moisture? Additional moisture in the air, that sort of thing. Tom, maybe start with you on that.
Yeah, so we've done a little bit of work on air quality, probably back to 2018 or 19. We did some ammonia measurements in barns. We did relative humidity. I would say so far from what we've seen, the air quality is not, it's not presenting a particular issue. But this relative humidity and moving that moisture out is something that you just can't underestimate the importance of it, because all of it not done well affects the pack conditions. So you think of air quality, we think of relative humidity, we think of fog, and fog can be misleading too, because a really, a 15 degrees Celsius, basically a cold pack from a composting perspective, when you cultivate in February and it's -20 out, will generate a ton of fog, even though I would say your activity in the pack is minimal at best. So fog by itself is indicative of, you've released a whole bunch of moist air into cold air. I'm much more interested in the fog removal from the barn than I am the generation of it. So if it's not clearing out in minutes, I would say that it's more of a ventilation issue than the actual development of fog. Fog itself is a challenge to anyone in the barn. Nobody wants to hit a cow. Nobody wants to be not being able to see their hand in front of their face. Legitimate problem for sure at certain times of the year, but it's not insurmountable. And we don't see that it's creating other broader issues in terms of cow health or anything like that.
Christoph, put this whole thing in perspective for us too in Ontario. So it was probably 7-8 years ago, the first time I was in a compost bedded pack barn. Is this new? Is it growing? Why the trends? How many, what percentage? Is it 1% of the dairy industry? Just can you give some perspective to this in Ontario anyway?
Well, Tom would have to give you those. Tom can give you those statistics in a moment. I don't. do we have 100 of these barns, Tom? And you can divide it by whatever our denominator is of how many barns or farms we actually have, right? Because again, that would be a different denominator whether or not we're measuring farms or barns, right? Because the way the industry is consolidating at present. I would say it's niche. Andrew, if we're being frank, I think it's niche, but I think it's an important niche because we need to get people out of tie stalls. Okay. And so what we've not talked about is that the people who are attracted to composting bedded pack barns, and I just want to say, I always say composting, right?
Okay.
Because to me, it's an active process. It's not finished compost. It's different than people who are taking finished compost and bedding free stalls. Okay. It's sort of inside pool to dairy people, but I think there's a difference. So the challenge is that we have people in tie stalls who need to get out for business reasons and frankly, industry trajectory momentum reasons. And many of them are distrusting of free stalls and platforms. And our good composting pack managers are also good cow people. They're people who see cows. They can tell a day before any analytics shows a cow is becoming ill. They see it. You know what I'm talking about? Okay, the animal managers know what I'm talking about.
Yep.
Those are the same people who can make packs work. They love their cows. They hang out with their cows on the pack. They walk the pack. They want to be with their animals. So this is a good fit for some of those people who want to get out of tie stalls. So to us, it's an important niche that we need to support. Because we also fear in the dairy industry that there's a bit of this no man's land, right? It is not a small thing to expand a dairy at this point in time.
Mm-hmm.
It's kind of a critical zone in terms of herd size that, is in a real challenge in terms of can they bite off a chunk to grow? And for some of them, this transition into these pack barns gives them all sorts of flexibility, which is a talk for another day, that interrelates with that building envelope. Because worst case scenario, they can rip out the pack and put in platforms. Worst case scenario.
Mm-hmm. Yeah. Tom, anything to add to that or?
Yeah, just in terms of the system itself has been around for quite a while. I would say probably our longest experience in Ontario is, plus or minus 20 years or so. And some of these places, a lot, I would say, would be within the last 10 and quite a few more within the last 5 or 6. But I would say, yeah, it tends to be that demographic that is looking for an alternative, and for various reasons that Christoph's mentioned, doesn't like some of the other options that are out there, and this is something that appeals to them. So I think it isn't important. I agree with Christoph. We don't really have great numbers on what this would look like in terms of total number of farms. I think if we went out systematically and, could survey this, I think we'd probably be in the 100, 200 out of 3,200 dairy farms that are out there today. So it is niche, but I think as Christoph pointed out, it's an important niche.
Right on. And Janet Harrop, I know you're on the call, and if there's a reason that you're involved and have one on your farm, throw that in the chat too. Would be happy to hear from you. Bedding materials, and absolutely, I know the first farm I was on, they were using sawdust and very concerned about supply. And so you mentioned some of the other materials, straw, and so on. I was curious when you mentioned MDF. When I think of MDF, I also think of glue and the other substrates that are part of that. Are there any issues there around some of those engineered products?
So I think we know a little bit about that, probably need to know more. So people are attracted to that product sometimes on a price basis and sometimes on an availability and supply basis. We do know they don't tend to compost as well as a kiln dried hardwood, finely ground sawdust, which would be like on our A list of materials. But we also know that they can work. We tend to know that they have good absorbing capacity in terms of moisture management. They don't always achieve some of the temperatures that a true straight hardwood sawdust supply would do. And we've got some people who are kind of blending materials. So they'll use sawdust and MDF sometimes together in combination or alternate loads. It's definitely, supply is very local in some cases. So people are using supplies that they have access to, and sometimes they are drawn towards things like MDF because it's readily available in their geography.
Fair enough. We're just about out of time here. One more question in terms of barn style. Noticing much difference between a barn with turkey curtains versus tunnel ventilation in regards to moisture, let's say. You see much difference there?
I'll bounce on that. I think these barns, there is a limit. There's a few of them that are tunnel ventilated, Andrew, to your question. So mechanically tunnel ventilated, and it can work to a certain barn size. The poultry industry, I think, understands this better than we do. And when I say we, I'll blame us group of colleagues, because they're a mechanical tunnel ventilated barn will only work to a certain size in the poultry industry, right? And then you're going to get into moisture saturation as that air comes through the building, if you understand what I'm getting at. So I think it can be a good fit to, you may say, 100 cow barn. Because keep in mind, Tom put that graphic out there about the 120 square feet and the 60 liters of water we got to get out. This is still a little different than that freestyle barn where we're scraping out all that liquid manure all the time. We have to drive that moisture off the pack. It is in the barn, right? And the better job we do that fog that you guys have discussed and get that into the air, we have got to get that out. So there's going to be a physical limit, and some engineer smarter than me and not as lazy who will actually do the math will tell you that these barns can only get a certain size if we're going to tunnel ventilate them. So I think for anyone getting into larger barns, they're going to have to be turkey curtains, and taking any airflow you can get.
Right on. Just draw people's attention to the chat. There are some good comments as well. Jim made some comments. Janet did. I'm going to pose one question, and after I pose it, I am going to put up the KSE QR code. So for those folks that are looking to get an off-calf credit, that QR code is for you. If you have questions on that, Madeline from OSCIA is active in the chat and can help you there. But I'm going to pose you this question to answer, please, while this is posted, guys. This is from Jim. He's wondering if you have a number you use for percent manure drop on the pack versus percent manure drop on the alley, and does the open versus limited access affect those numbers?
I'm hoping Christoph will take this one because it's a nutrient management type question. But the answer to the second part is that I don't think open or restricted access would affect that. Some of it will be dependent on the chosen width of the scrape alley. So our current recommendation is 14 feet. We've certainly got barns out there at 12 feet or 13 feet. I'm trying to remember off the top of my head what the N-man called for as the split. I'm thinking it was 30-70, but I'll defer to Christoph on that. And yeah, go ahead, Christoph.
I'll answer that without hemming myself in on specific numbers. Like that example, Tom, you used before, having alleys on two sides of the pack, right? It describes this dilemma that Andrew's asking about, right? Or Jim, I think Jim's question that you read out. I think alley width matters. I think one or two alleys matters. I do think the continuous access matters, because someone put in the chat about boss cows too. And if boss cows are controlling those openings and more timid animals are not making the trips to the bunk they should be, that means they're going to leave their urine and manure on the pack also, rather than out there on the scrape alley. I'm pointing to my imaginary scrape alley over here. Sorry.
Yeah, I apologize.
So
I haven't kept up with the chat other than what Andrew's flagged towards us. I see out of the corner of my eye, Janet's got a question here about breeding animals absolutely on a pack. That's an issue for lactating cows going through heat as well. Sometimes they can really rip up a pack. So I think there's something in here about your question about heifer pack, but I haven't totally read it yet. So happy to chat afterwards.
Okay, so I'm going to post one more QR code. This is for the Certified Crop Advisor credit. While that's up, gentlemen, I'm going to ask you to just deal with one more. You referred to it basically as more of a future work, so I get that. But in terms of greenhouse gases, do you have some thoughts now in terms of how this fits in? Is it worse? Is it better? Is there? You got any parameters or any thoughts on that in terms of greenhouse gases?
So worse or better is always relative to what, I guess, is the first question. I would say there's an inherent advantage to a solid manure system versus a straight liquid system in terms of greenhouse gas emissions. So regardless of whether we're talking a 50-50 split or a 70-30 split of liquid to solid, there is going to be an advantage over a freestyle 100% liquid environment. If you were purely like into a tie stall solid manure system, essentially, it may not measure up quite that well, but I think it would be a very relatively small difference. I think there's a real advantage on the environmental side for these facilities from that perspective. Not to say everyone should rush out and build them today, because I don't think we have enough sawdust, and everyone would hate me if I suggested that.
Yeah, and if you go back to that project team on the U of G study, Andrew, right? Like that is the motivation of Gordon Price and Rob Gordon to be involved, right? Is that they see a potential that carbon product that's coming with sawdust is holding some of that nitrogen that might have been blown off otherwise, or some of that methane that might have been blown off otherwise, holding it in the pack, not only as a carbon source, but also as a nitrogen source. And again, there's people on this call that are smarter than me and understand composting that can validate or refute that. But that's the fundamental math, is that by bringing in this carbon source, we tie up that stuff in the pack until we use it as a nutrient. So yes, that's why those guys are on this project.
Right on. Guys, I got at least 5 more questions, more to discuss, but we're going to have to call it there. I think we'll go with Dana's comment in the chat, which is voting for a part 2 of this session to continue the conversation. So we'll take that comment, Dana, and I think put that to heart in future Manure Monday. So Christoph, Tom, thank you to both of you. Appreciate the work you're doing. Appreciate you sharing it with us today. And folks, we hope to see you back again next Monday. It is our final Manure Monday as we look at biosecurity for disease prevention. We will have Al Dam from OMAFRA and Susan Fitzgerald from Fitzgerald & Co. And they'll be looking at different diseases, transmission, prevention, and biosecurity. So that's going to be an excellent topic. Same time, same place next Monday. We look forward to seeing you then. Cheers.